Here's a great example for you. And if you remember what this equation looks like, yeah, that's a semicircle with a radius of 2. So I went out and I drew it for you down here. Okay, so it's a semicircle with a radius of 2. Of course, we're at the origin right here. There's our radius of 2 going that way, radius of 2 going that way, radius of 2 going that way. What a beautiful way to explain vertical transformations. Check this out. It says, write the equation which represents a 3 in front of the f of x. Well, think about this. This is the f of x right here. This is the 4 minus x squared. There's the f of x. All you're going to do is stretch by a factor of 3. So you put the 3 on the outside. There you go. There's your new equation. Now, we're going to sketch this particular thing. Now, remember, this is a vertical. So that means it's only going to affect the y coordinates. That's what it's going to affect, the y coordinates, because it's a vertical stretch away from the x-axis, or technically about the x-axis. All right, so check it out. Think about this. What is the coordinate here? What is the coordinate here is minus 2 comma 0. So the vertical coordinate is 0. Okay, so we're going to multiply that by 3. Well, 3 times 0 is still 0. There's our point. Aha, that's an invariant point. Oh, remember that word? Aha! Now, look at this point here. That is 2 comma 0. Again, the y coordinate multiplied by 3, 0. So you actually have 2 invariant points here. Now, the only other coordinate that I see that's really, really obvious is right here. Now, take that coordinate, which is 0, 2. There's the y coordinate multiplied by 3. Guess what you're going to get? You're going to get 6 way out here. So what does this new graph kind of look like? This new graph is going to be stretched to look like this. It's no longer a pretty semicircle. It's actually stretched vertically by a factor of 3. Okay, so that just describes, guess what? Part C says, describe how the number 3 in this affects it. This is going to be stretched vertically by a factor of 3. So you can even put down that all the vertical coordinates are multiplied by 3. Wow. Now, look what happens here. I've put some important stuff down. Look at this. What about those x-intercepts? Well, those x-intercepts were originally zeros. So multiplying by whatever you want isn't going to change the x-intercepts. These stay the same. Okay, and the reason why they stay the same is because, of course, they're a 0 coordinate to begin with, and anything times 0, there you go. Now, means no change. How about that y-intercept? That y-intercept, which was right here, we know that that y-intercept was multiplied by 3. So you take the y-intercept, and you multiply that by the scale factor in 3. In this case, it was 2 times 3, which gives us a new intercept of 6. Why are we worried about that? Because remember, the scale factor, right, in a vertical stretch affects our y-intercepts, all y values, including our intercepts. Now, can I show you how to do this using VARS on the calculator? Of course I can. What I need to do, though, is I need to write down what the original equation was. The original equation was this guy right back here. Boom. Let's use VARS to actually prove that the graph is going to look like this monster here. Okay? All right. So let's go set that up right now. So what I've done is I've done this for you. I've put the square root of 4 minus x squared in there. Now, a couple things I want to show you is I've changed the window around a little bit as well, because I know what the graph is going to typically look like. Remember, it's going to have a radius here of 2. So why do we need to go to minus 10 plus 10? Okay. The other thing that I did is I got rid of the y minimum. I made that a minus 1 so that you could at least see the y axis and the x-axis. Okay, so let's graph this. Let's see what it looks like. And there's our nice little semicircle right there. Now, using VARS, go back to here, and I'll show you both ways of using the VARS, okay? I'll show you if you don't have the new calculator, and I'll show you if you have the old calculator. Let's do the old calculator first. So we're going to hit the VARS button, boom, okay? We're going to go to YVARS. We're going to pick the function that we want. We want function number 1, and you see that it pops that function right here. Now, if I put y1 and I hit graph, it's just going to change this blue line to the red line because I haven't changed y1 at all. Okay, I haven't applied any transformation to it yet. And I'll prove it to you. Watch. Boom. Ta-da! Changed it from blue to red. Now, let's go back to here and let's remember that we want to increase this by a factor of 3. Let's see what it looks like. Okay, so I'm going to insert a 3 in front of this f of x, and I'm going to graph it. There it is, exactly as I showed you on the graph. And if you look, count it. 1, 2, 3, 4, 5. There it is. There's the y-intercept at 6, which was the original intercept at 2 multiplied by the scale factor that gives us this. Now, you're probably saying, well, wait a second. Why doesn't this go all the way down and touch here? Well, one of the reasons why is because, again, you're dealing with a TI-84. TI-84 is not a high-definition calculator. Sure, it's pretty, it's got some beautiful stuff on there, but unfortunately, there's no high def, okay? So, go back now, I'm gonna do this exact same question again, but this time, if you do have the new calculator, I'm gonna show you how to do that with the new calculator. Okay, so let's clear this out of here. Let's clear these marks off here as well, and here we go. So with this, you would have to go, okay, I wanna multiply this original function, which is y1, by 3. I'm going to choose y1 by going alpha f4. There's my y1, and look how pretty that is. Hit graph, and bing, there it is. Okay, so that shows you some really cool stuff, and we're going to expand on this an awful lot in the next few podcasts.